Hello class, welcome to our second section dealing with graphs of sine and cosine. The other day we talked about how to set up graphs, where they start, how to find the period, how to find the amplitude. Today I'm focusing just on equations and how to find those things. Graphing wise, remember the starting point for sine should be the origin. The starting point for cosine should be kind of up and down from the origin at the equilibrium. And so if there's a 3 out front, so start up 3, for example. Okay, there's 4 questions here. We're looking for the period and the amplitude. So I didn't graph any of these things here. A lot of your questions kind of have the graphs for you to look at. So my focus is on the other pieces. So for this first one, the amplitude is 3 because the number out front is a 3. The period is 2 pi because there's no number in front of x inside of the trig function, so that's why it's 2 pi. Amplitude is 2, period here is pi because 2 pi divided by 2 would be pi. This one here, negative 2 sine x, the amplitude, remember, is 2. The amplitude is the absolute value, essentially, of the a value. It has an x-axis reflection, and the period is still 2 pi because there's no number in front of the x. And for this last one here, the amplitude is 3. It has an x-axis reflection, which means it flips over. And then the period should be 2 pi divided by 4 because there's a 4 here in front of the x, which would be pi over 2. Next set of questions, similar ideas, just to highlight a few things like this 8 right here. So 2 pi divided by 8 should be pi over 4. Remember that when it's x over 2, you could rewrite that as 1/2 x. And so 2 pi divided by 1/2 is actually 4 pi. It actually gets larger, which makes sense. If a number is multiplied by x, it should shrink down this way because it's going faster. And if it's division, it should go the opposite way, which means you should pull it out in the opposite direction and make it a little bit wider of a graph. Remember x-axis reflections if there's a negative sign. Notice that this one in the bottom left is negative 2 cosine of 2x. Negative cosine of 2x. This negative sign, that's a 1 still, so the amplitude is still 1, but it has an x-axis reflection. These 2 questions, you got 3 over 2, so that's the amplitude. Same idea, this is x over 3. You could rewrite that as 1/3 x, so it's 2 pi divided by 1/3, so that's actually times 3, which would be 6 pi. Next one, you got a 5 out front, cosine of pi over 4x. This is where anytime there's a pi inside with the x, they should kind of cancel themselves out. You'll get some type of integer or fraction without pi in it as an answer. So this is 2 pi divided by pi over 4. That's multiplying by its reciprocal, 4 over pi. The pi's cancel, and 2 times 4 is 8. A lot of real-world applications will have this so that the x-axis will be numbers that are relevant to the public and the common person that doesn't understand everything about pi over 2s and pi, etc. Okay, so the goal of a lot of those questions that you'll notice with real-world applications is the equations are set up in such a way that they adjust these pi numbers so that they become whole numbers for the period. Okay, negative 6, remember the amplitude is 6, that's an x-axis reflection. You've got 4x over 5 inside the sine function, so that's 2 pi divided by 4 over 5. Multiply by the reciprocal, you get 5 pi over 2. You're going to want to write that answer probably as a rational type number, which is a fraction. Obviously, it's not a rational number because pi is involved, but without pi, it should be a fraction, and then throw the pi in the numerator as long as it doesn't cancel out. Negative 3 sine of 1/6x. Notice this one's set up the way you want. It doesn't have that division like this first one did. So the amplitude is 3. It has an x-axis reflection. And then 2 pi over 1/6. Remember, it's 2 pi divided by the b value, which is the number in front of x inside the trig function. So then it would be 2 pi divided by 1/6, which is times 6 over 1. That should make it go kind of stretched out in the x-axis direction, which makes the graph a lot wider, as 12 pi instead of the typical 2 pi. When you're looking at these questions, if you can answer these pieces, I think the graphs will get better and better, but as you're going through your homework, you may want to write down some of the graphs so you have something to look at to correlate with so that you can see, oh, okay, I can see that this graph goes with these numbers and how do they go together? Because sometimes the graphing part is the hardest piece to deal with in this scenario. Have a good day, everybody.